Today we'll start with the first chapter of chemistry, that is language of chemistry. Now, chemistry by itself is, we'll be learning it as if it is a language. Like why we call it as language? Because we are going to learn the ABCD of that particular thing. Then we are going to learn the 2-letter, 3-letter words, the formation of sentence. Yep. Yeah, exactly. That is what we are going to learn. Because first of all, what we are going to learn is ABCD of the chemistry. What is ABCD of chemistry? The different symbols of the elements what are there, they are going to form the ABCD of chemistry. So chemistry ka ABCD is nothing but the symbols of the different elements. When I tell you that we are going to learn the 2 letters and 3-letter words of chemistry, they are nothing but the names of the compounds. The compound formation kaise hota hai? Why NaCl and not Na2Cl2 or NaCl2, why not that way? Why only NaCl? Why H2O and not HO2O or HO2? That is the reason we need to, like how we spell a normal word. Here also we are going to use the symbols in such a way that we are going to have a particular compound only. So that's why that is the 2 letters and 3-letter words. And then comes the sentence formation, is nothing but the equation. When we are going to frame an equation of that particular thing, it gives rise to what we call it as a sentence formation. So that's the reason we call this as a language of chemistry. Now the language of chemistry originally we can say it is it went out in this way, that maybe that each and every country had got their own language, and that own language had got different ways of telling the names of different elements. Like for example, in India itself, different languages are there, and we name a particular vegetable in a different way in one language and a different way in another language. So there is always a confusion that what exactly we mean to say. Similarly, there used to be problems regarding the names which are given to the different elements, and hence what they decided was that even if the element is named in any particular form, the symbol which will be used will be based on a particular name only. Like for example, even if we have sodium as SODIOUM, it is nothing connected to N and A, but still the sodium is given as, so we give the sodium as Na. Why we call it as Na? Because it is basically coming from the word natrium. So natrium is the name given to this in a Greek form, so the Latin form. So Latin word natrium ka short form is Na. So in this way, the use of Na, even if it is sodium, we call it sodium, but we are going to use it in the form of language of chemistry, we are going to use it as Na. So that is one of the way we are going to see to it that throughout the world, everybody is using the same kind of the symbols so that it is identified properly throughout the world. So that is one of the reason why language of chemistry is very important. So first of all, if we define symbol, so it is, you can say symbol represents a specific element or one atom. Okay, one atom or an element is going to be represented by a symbol. So symbol represents one atom or an element of a substance. Similarly, symbol also represent a symbol also represents the weight of the element equal to its atomic weight. So when I say Na, what I mean is also that the mass of sodium with respect to 1/12 of a carbon atom. So the Na, that is the mass of Na, is also going to be represented by this symbol. Initially, there were many other ways by which the symbols were going to be generated. Like in the initial stages, John Dalton, he suggested that because at that time there were hardly around 16 to maybe 30 kind of elements, so it was easy to identify them in case of symbols. So they considered that oxygen to be given as a circle, and hydrogen to be a circle with a dot. So this was hydrogen, this was oxygen, and then there was sulfur, which was like this, a plus sign inside, so it was center makes a plus sign, or it could be just one line and one line over here to be nitrogen, this was sulfur. In this way, there were many things formed for the formation of the symbols. But as and when the number of elements kept on increasing, it was very difficult to remember कि ये लाइन में नाइट्रोजन या ये लाइन में नाइट्रोजन या क्या होगा, दोनों कट करेंगे तो क्या होगा, ये क्रॉस में होगा तो क्या होगा. So there were many confusions which were coming up, and that's why this particular symbol representing as a symbol was discontinued or abandoned because it was too cumbersome. And then Berzelius suggested a new method, and that was nothing but the use of the first alphabet or the first two alphabets for the formation of the symbol. So what they did exactly was very simple. They said that what should be a symbol be? The symbol will be, first thing will be, the symbol will be the first alphabet. So all the major kind of the elements which are very normally found in nature, they were given the first alphabet. Like for example, carbon was C, oxygen was O, nitrogen was N, hydrogen was H. So this was given to them. The next was, of course, there was not only one with C, like copper है, then there will be वो nitrogen के साथ में यहाँ पे दूसरा अपना sodium वगैरह आ जाता है, Na वगैरह आ जाता है, तो automatically there will be different substances which were there with the same alphabet. Hence, for such things they said it was first two alphabets. So when it was the first two alphabets, then we got the certain things, like in case of copper it was Cu because it was cuprum in Latin. Then it was Fe, that is iron, in case of ferrum. Then Na, that is natrium. Here it was K, that is for potassium. So in this way the first two alphabets were given that particular thing. Still it was not so clear because many things were uncertain. Like for example, if we take about the third one is, suppose I take as magnesium and I say manganese. So in case of magnesium and manganese, it was always difficult कि पहले दोनों में Ma आएगा तो क्या करेंगे. So it will be first letter and plus prominent letter. The most prominent letter after that will be taken. So over here it will be Mg and Mn. Similarly for chlorine. So you can see chlorine starts with CH, but we call it as Cl. So that's the way the symbols were maintained. Now of course the symbols were given to the name which was more prominently used throughout the world, and that's the reason there was not only English names which were given the symbols, or the name given with the help of the symbols were not only the English names, but also some Latin names which were very prominently used throughout the world. So that's why carbon, sulfur and all were just the normal one which were English names, whereas so here it was S and C and all. But when it came to the thing like over here, like bromine and all, it was Br and all because it was same thing in English. But here when it is Latin names, so these all are due to Latin names. Cuprum, Latin name for copper. Ferrum, Latin name for iron. Na, sodium, that is natrium, Latin name for sodium. So kalium, which is K over here is kalium, which is for potassium. Then silver is argentum, Ag, which is for, in this case, that is Ag. Argentum. Plumbum, which is for lead is plumbum, so Pb, okay, again in this case plumbum. And mercury is hydrangnium, which is Hg. Hg is mercury. So all this way we can say they adapted the three things either in English or in Latin name. That was, first one is the first alphabet, second one the first two alphabets, and the third one as the first and the most prominent alphabet which is coming in that particular name. In this way the names of the symbols or the elements were given a particular symbol over here. So that was the first thing. So this is how the alphabets of the language of chemistry was determined. Now once the alphabets was determined, the next thing was the formation of the compound. So when we talk about the formation of the compound, you need to know one very important thing about the compound, about the particular element, and that is the valency. Now valency plays a very important role in the formation of the compound. So अगर हम लोग valency देखते हैं, so if the next thing is what we need to know is the valency of element. Because only if we know the valency of the element, we can frame that particular compound, the formation of the compound, or we can say the compound का formation name कैसे दिया जा सकता है, that was possible only with the help of valency. So, okay. Now, in case of valency, the normal substances, we can say the one which are usually there, which obeys the octet and the duplet rule of the atomic structure, they will have a single valency. When they have got a single valency, it is not a problem at all. They are just some normal ones. Like for example, sodium, potassium, Na will be having only one. That's why it is given as 1 plus. Potassium has got one, that is 1 plus, right? But there are certain substances which are going to be having multiple valencies. Now this is because they are that kind of substances which can complete their outermost orbit even without completing the penultimate or second last orbit, and that's why they have got variable valencies. So when any substance has got more than one valency, they come into the category of variable valency. So now valency can be of two kinds, of course. We know that way, that it is one which is positive and other is negative. Of course, the positive ones will be the one which are metals, and this one will be non-metals. Also, there will be over here radicals. Okay, this will be radicals which will be non-metals. Now, first of all, what is variable valency is that certain elements exhibit more than one valency, hence showing variable valency. Reason for exhibiting variable valency is an atom of an element can sometimes lose more electrons than are present in its outermost valence shell. So loss of penultimate or last but one shell exhibits more than one variable valency. So that is why copper has got two valency. Valency is +1 and +2. Okay. Similarly, iron has got two valency, Fe2 and Fe3. We have got plumbum, that is lead, has two valency, 2 and 4. Mercury has 1 and 2. Accordingly, you have got different substances having two valencies. Now, the names of this particular elements are also given in a proper manner so that you can identify the valency of that particular element. So it is this way that in case of positive valency, one will be lower and other will be higher. Like for example, in case of ferrum, that is iron, it is either 2 or 3. Now the one which is higher, the higher valency is given as the suffix as IC. That's why this UN gets cut and it becomes ferric. Okay, ferric. Ik means higher. IC, when an IC is added at the last of that particular element, it is a higher valency. And if it is less, it is called as us. So it is ferrous. So ferrous is Fe2. So it is ferrous, which is Fe2 plus, and ferric, which is Fe3 plus. Got it? Accordingly, if I say cuprum, so cuprum is a normal copper. Now if it is cuprous, it is valency 1, Cu plus 1. If it is cupric, it is valency 2, Cu plus 2. So cuprous, cupric. Similarly, if it is mercury, or let's say, okay, mercury. So mercury will be mercurous and mercuric. If you get silver, argentus, argentic. Okay. Us means smaller valency. Ik means higher valency. Us and ik is going to be defining whether the valency given to that particular element is higher or lower. As per the new IUPAC name, you can also call it directly as iron 2. Here it is iron 3. Okay, this is iron 2 and this is iron 3. Okay, as per the new IUPAC names. But normally you should know that what is cuprous, cupric, ferrous, ferric and everything. You should know. So that's why it is us and ic. Now, then we see is, so this is about the positive. In case of positive radical, you don't have much of a confusion. It's only us and ic, and that us and ic is only because of the variable valency what it is having. Now let's see about the negative valency. In the negative valency, what we see is that apart from the different elements which are there in the negative valency, like in case of oxygen, hydrogen, nitrites. So apart from that, there are also going to be certain kind of atoms which have already combined, but even after combination, they have got certain valency balance in them. So when this compound, or when we, not a compound, but a group of atoms, okay, is going to be such that they have got a valency of their own, they are called as radicals. So radicals are group of atoms that behave like a single unit. Okay, they are group of atoms which behave like a single unit and show a valency. So when a group of atom which behaves as a single unit and have a single valency of its own, we call them as a radical. For example, it could be OH, which is OH minus. That is, OH is hydroxide, which is a combination of hydrogen and oxygen, and has got one valency, that is, it requires one electron to complete its orbit. Similarly, there could be nitrate, which is, or it could be like sulfate, SO4. That will be, all these will be the formation of a radical. So, and each of this are going to be having their own valency. Like nitrate will be having valency -3, this will be -2. So accordingly, this will be the group of atom which behave as a single unit and has got its own valency. So that is a radical. So when I say that one atom has got only one valency, they are called as monoatomic, or we can say as monoatomic will be the element which will be only single part, that is sodium, potassium and all. Whereas hydrogen, oxygen, nitrogen, chlorine, bromine, bromine, iodine, these are the ones which are diatomic structures. So they are always going to be in twos. So chlorine and all would always be NCl2, F2, N2, O2. So it will always be this way. So in a formula, whenever you are writing oxygen, it will be O2 because it's a diatomic structure, right? Remember this thing, because whenever they give that something plus, or like hydrogen plus oxygen gives you water. So I cannot just say H plus O giving me H2O. It will be hydrogen will be H2 because it's diatomic structure. Oxygen will be O2 because it's a diatomic structure, and it forms into water, which is H2O. So that is the formation over here. Now you can see in case of the radicals, the negative radicals also needs to be given proper names, because if they are not given proper names, we will not be able to identify them when we are writing it in the form of sentences. So over here, it is normally seen that the radicals will be such that if the radical is the only element itself, okay, if it is that own element itself, it is given the suffix as IDE. That means only element is ID. Like for example, chloride, which is a Cl minus, oxide is O minus 2, the nitride, which is N-3 minus. Okay, this is all single, that element itself. If the element is alone, then we call it as IDE. When I say IDE at the end, then it is going to be that element itself, and hence it will be just that single thing. Like chloride will be only Cl with minus, oxide will be O with -2, nitride and -3. So these are examples of ides. So nitride, sulfide will be just S. Okay, phosphide will be only P. Okay, so these are the examples of IDE. Now comes the formation of the negative radicals normally involves the presence of oxygen and hydrogen. Now in case of presence of oxygen, we are given that if the number of oxygen molecules could be such way that it could be SO3 or SO4. The sulfur can be combined with oxygen to form a radical as SO3 2- or SO4 2-. So the names which are given over here for lower amount of oxygen presence is with the suffix of ITE. That's why it is called as sulfite. That is ITE, means less number of oxygen. Here the oxygen is more than this, it means ATE. That's why this is called as sulfate. So ITE for less oxygen, ATE for more oxygen. If no oxygen, IDE. Less oxygen, ITE. More oxygen, ATE. This is a simple way to remember this thing. Okay, so if I talk about sulfide itself, so this will be like this, that sulfide IDE will be S2-, sulfite is SO3 -2-, and as sulfate will be SO4 2-. So here these are the three ways in which a sulfide itself is forming a radical with or without oxygen. If no oxygen, sulfide, more oxygen, sulfate, less oxygen, sulfite. Okay, sulfide, sulfate. Now similarly, if hydrogen is also involved over here, like if it is going to be HSO3, then it is going to be just a bi added to a prefix. So it will be bisulfite. Sulfide remains as it is, but a bi is added to it. If it is carbonate, it will be bicarbonate. A sulfate, a bisulfate. So a bi indicates a hydrogen being added to this particular radical. So a radical having hydrogen in it with the normal radicals of sulfide or sulfate will become bicarbonate, bisulfate, and things like that. So that is the formation of the negative radical over here. So it's very, very, very important for you to learn the radical chart, I had already given you the radical chart on the first day of the class. So that radical chart you need to learn by heart, because that radical chart is going to help you to form the compounds. So if you talk about the textbook, then we are talking about this textbook here. In the textbook, this is over here. These are all the radicals over here which are positive. These are the radicals which are negative. The positive radicals which are even variable, and these are variable negative radicals. So this is valency 1, valency 2, valency 3, valency 4. Here valency 1, valency 2, valency 3, valency 4. Okay, for negative and positive. You need to learn this thing by heart. Now we move forward to form the compound. So how to form the compound? It's a very easy thing to form a compound once you understand the concept of radical and you remember the different radicals which are present, or you remember the valencies of the different radicals which are present. So when you talk about the it's very simple. Like suppose I want to name sodium chloride. What I'm going to do is just write the symbol over here with the radical, with the valency. So it will be Na. Valency is 1. This is Cl with a valency 1. Now you just cross multiply, both are 1, so it just becomes NaCl. Okay, that is NaCl. Let's take another example. Well, I'm taking as aluminium. Let's say chloride. Now aluminium has got a valency 3, whereas chlorine has got a valency 1. So when you cross multiply over here, it becomes AlCl3. Okay, that is aluminium chloride will become AlCl3. You need not remember that aluminum chloride is AlCl3. You just need to remember the radical chart over here. If you remember that aluminium is 3 and chlorine is 1, automatically you know that aluminum chloride is going to be this way. Now let's take another example, which is nothing but ferric sulfate. Ferric, we know that it is Fe and ic means 3, so it is 3 plus, so 3 over here. Sulfate is SO4 and its valency is 2. Okay, this Fe was 3 plus like this and this is 2 minus like this as per the radical chart. So this is 3 over here and 2 over here. So you cross multiply here. So that becomes Fe2 and your SO4 is 3. Now because SO4 is a complete thing over here, we need to put a bracket over here and see over like. And when I speak this thing, I say it as Fe2 SO4 thrice. I don't say Fe2 SO4 3. I say Fe2 SO4 thrice. Same thing if it would have been ferrous sulfate. Let's say sulfate over here, then it will be Fe2 plus and this was SO4 2 minus. So here it is 2, here it is 2, then they can be cancelled and hence it becomes FeSO4. Got it? So when the valencies over here are going to be the same, then we can cancel those things. That means that whenever you are giving any particular name of the compound, the name of the compound will always be reduced to its lowest form if the valencies are of the same multiple. So if this is 2 and this is 4, then it will become 1 and 2. So accordingly, you will have to see to it that you are writing it in the lowest form, that is FeSO4, even if it would have been Fe2SO4 twice, but we will write it as FeSO4. Are you clear with this? Now, so we have got different methods of, we have got different elements with compounds which are going to be formed. So normally all the compounds are formed in this particular manner, that you are going to write the name and then the individual symbol and its radical and its valency and give you the proper name. But there will be certain things which are not going to work this way, and that are the names of the acids. Acids are going to be named after their negative radical. Like for example, if I am saying hydrochloric acid, it is hydrochloric acid, then it is chlorine over here, so it will be HCl. Hydrochloric acid is HCl. Sulfuric acid will be H2SO4. Okay, sulfuric. So that is why the bigger ic, here we are using the same method of the positive radical. Ic means of a higher valency, so SO4 of the higher part. अगर sulfurous बोलते हैं तो sulfurous acid will be SO3. So that's why we have got over here as, if I talk about H2SO4, it is sulfuric acid, whereas if it is H2SO3, it is sulfurous acid. So you can see the lesser number was us and greater number was ic, as what we had in the positive radical. So sulfuric acid, sulfurous acid, carbon के साथ में जो होगा वो carbonic acid is H2CO3, that is nothing but formed by the carbonate. Then phosphoric acid will be a phosphate, where it is H3PO4. So all these are going to be the formation over here for acid. Similarly for the bases are going to be formed of hydroxides. So when I say potassium hydroxide, then it's the same thing, it is not going to be a problem. So it is potassium hydroxide. So here I don't need to do anything further. Potassium is K and hydroxide is OH. Here it is minus, this is minus, so it is plus 1 and 1, so it will be KOH. So here you don't need to change anything. Here only in case of acids, the names are not prominently given based on the formation of the compound. So hydrogen के साथ में उसका कोई formation नहीं है कि hydrates of this, ऐसा नहीं है. It is just like hydrogen chloride will be HCl. Otherwise, all the salts and all will be formed by this particular method of cross multiplication only. So you just need to learn the complete radical chart. If you learn the radical chart properly, all the different kinds of compounds which can be formed using this thing can easily be noted. There is no problem at all in formation of any of these compounds. Even if the textbook gives you a list of different forms over here, different list of the compounds which are formed over here, the different formulas over here, not so important. You can just easily learn them by knowing this particular formulas over here, except for 2 or 3 things which I'm going to tell you now. Now there are certain things which are called as mixed salts. See, normal, these are all as FeSO4 and all are normal salts. But there are certain which are mixed salts, and when these mixed salts are there, these mixed salts normally have got more than one positive radical in them. For example, we have got over here as tetraamine copper sulfate. Okay, it is tetraamine copper sulfate. You need to understand, sir, the name properly. Tetra means 4. Amine means ammonia, that is NH4, and copper is Cu, and this is sulfate, which is SO4. Okay, tetra 4, tetra pack, and nothing but it has got 4 layers. That's why it is called as a tetra pack. The fruity का वगैरह का जो pack होता है, it has got 4 layers. That's why it is called a tetra pack. So the tetra means 4. Amine is having a presence of ammonia in it, that is NH4, NH3, ammonia in it. So ammonia, so that is NH3, ammonium is NH4, ammonia is NH3. So it is tetraamine copper sulfate can be given as, first you will be writing the copper sulfate, so it is Cu, and then you are going to write over here NH3, because it's tetra, so it is 4 over here, tetraamine, and then it is copper sulfate, it is CuSO4. So that is CuSO4 and tetraamine, which is coming over here. There is one more of a similar kind over here, which will be given as tetraamine zinc sulfate. So if it is tetraamine zinc sulfate, so again the same thing, tetraamine, so it is NH3 4 zinc, the Zn, and then SO4. So the Zn NH3 SO4, that is tetraamine zinc sulfate. So these are certain examples which are slightly different from the normal thing, because you will not have anything like amine and all in the radical chart, because it's a mixed salt, as I told you. So that's why we will be using this kind of thing by just learning that thing properly. Otherwise, everything is going to be very much within the range in the period in the Valency chart. You won't have any problem with this particular formation. So this was the formation of compounds. Next we will learn is the chemical equations, but in the next video.